welcome everybody. I'm going to start off by thanking the organizers for inviting me to speak here. I've been involved sort of peripherally or on and off with security automation and interoperability for, I can't even remember how long, 15, 20 years. When did the whole NIST SCAP thing start? I helped run the workshop that started that. Yeah. And, as Duncan said, I was with NSA cybersecurity for many years. I just recently moved over to NSA research, but we have cybersecurity research in our research directorate. Things like supply chain and security automation and AI security are all big research topics for us. So, I had no trouble whatsoever getting approval to come here. And since I went through the approval process, I'm good. I don't have to ask for Chatham House rules. Just don't ask me any really off the wall questions, because then I'll have to say I can't talk about them. Right? Okay, so, and I have had the privilege of speaking at prior versions of this workshop. I have vivid memory of doing one in downtown near Union Station. Was that about 5 years ago, 6 years ago? AT&T were the sponsors at that time. Thank you. And it was a great event. And then it rained like heck as I was trying to get back to the metro. Completely soaked. All right, but
It doesn't look so great either.
yeah. But these events, I think, are really important. And I'm sorry I couldn't be here on the first day, but getting folks together, getting the technical folks together to work on these technologies, actually try to get them to work together, sharing experiences and tradecraft is completely essential to getting these technologies to work, to be ready for adoption, to be picked up in commercial products, open source products, and eventually to be adopted by the cybersecurity community. So I'm going to hit a few things here. I'm going to talk a little bit about trends that I see sort of from the NSA side in the environments that we are seeking to defend and protect. Then I'll talk about the importance of standards and automation, and along with standards, of course, comes interoperability for successfully protecting and defending. And then I'll hit a couple of specific areas like information exchange, a tiny bit about bombs, but you have a speaker who's a super expert on that later, so I'm not going to steal his thunder. A little bit about AI. Many of you know Michael Rosa, the colleague of mine at NSA. He sends his regrets. He's preparing for a big ITU standards meeting where he has to be helping run things. So that's why he couldn't be here. So he sends his apologies. I saw him yesterday briefly, and he's like frantically preparing.
I was just saying, I'm surprised he's not on a plane.
Oh yeah, and then he gets on a plane this weekend. So yeah,
he's to go to Geneva.
Yeah, it's true.
Yeah, yes, which he had to get all sorts of approvals for that, because we're sort of pinned down on travel in the government right now. So, but he did get approval because he's so important to the ITU efforts. So we'll hit a bunch of those things, and then here's all the AI stuff. It says write insightful notes here. Yeah.
Okay, tell your LLM to do that.
Yeah, I could have just gone to Claude or ChatGPT and said, write me some insightful notes about AI. I'm sure it would be self-complimentary. Okay, so yeah, I mean, AI, of course, has been huge lately, and we'll talk about that. But we have to keep our eye on the ball and realize that not everything needs to be AI. There's a very small anecdote about that. Our colleagues in Cyber Command came to us in the research directorate and said, will you please help us incorporate some AI into our operations to help us do our mission? And we said, sure. And we cheerfully helped them incorporate stable, effective machine learning into their operations. Because that, after we understood what they were actually trying to accomplish in that particular mission scenario, it's like, no, you guys need something straightforward. You're not looking for an LLM, you're looking for a machine learning classifier. And that's what we helped them to incorporate. Okay, so how is the environment changing, right? Many of us, and I know some faces here in this room, have been in cybersecurity for a while, and we have seen the environment change, right? We've seen pivoting from attackers being kind of very noisy to attackers being very stealthy. that's been particularly marked, I think, with Chinese nation state actors. 10, 15 years ago, it's like, oh yeah, those guys are really noisy. We see them all the time. People like Volt Typhoon, Salt Typhoon, they're very sneaky. They practice effective tradecraft to conceal their operations, and therefore they don't get caught as easily. Okay. Another trend, and I'll get back to Salt Typhoon, Volt Typhoon in a moment. Another trend that we're clearly observing from NSA, and I think this is be true in industry as well, is increasing complexity of the enterprise environments that we need to work on, that we need to configure securely and then maintain and then monitor and then incident respond in. One of the key drivers, at least in the government parts that I see, is increasing hybridization across on-prem and cloud, right? For a long time, for example, in the Department of Defense, yeah, you'd have some cloud workloads or cloud services, and you'd have a bunch of on-prem stuff, and they weren't tightly integrated there, like they're mostly separate. But certainly in the past 5 years, we've seen increasing integration of those things, where the on-prem systems are perhaps trusted by the cloud system to authenticate or provide privilege information or certain data flows. But then the cloud systems are doing mission critical stuff, so they have to authenticate users and impose access controls. And as those things have become more integrated, it becomes harder to defend them, or at least more complex. And one of the main reasons, and we certainly saw this with earlier attacks, is because those broad camps, all the cloud stuff and all the on-prem stuff, neither of which are simple in themselves, because they now have so many trust relationships to each other, that enables attackers to, if they can manage to successfully attack one of them, they can crawl over to the other one, utilizing those trust relationships. So that makes things more complex, because you have a lot of situations where you're trying to perhaps monitor for an external attack, but in your monitoring, it doesn't look external. It looks like it's coming from your trusted cloud workload, or it's in the cloud, but it looks like it's coming from your trusted host workload over your direct connection. Different cloud vendors call those different things. I do try to stay away from calling up specific vendors and products, because then my lawyers yell at me when I do that. So for the really sophisticated actors that we've been seeing lately, right, Volt Typhoon a little while ago, Salt Typhoon more recently, I want to particularly call out the trend in them using what people call living off the land tradecraft. All right, and this is, I think, I mean, certainly there are other trends, but that one in particular I'd like to call out because it's an analytic challenge, right? For many years, a lot of the defense that we worked on, and this was true of many of our industry partners as well, focused on detecting adversary tools, their malware, their exfiltration tools, things like that. And you could find them on your system with all sorts of methods, right? There were sort of allow listing methods, like here are all the Windows programs that should be on this Windows system, and this is not one of them, therefore it's suspect. Or detection methods with virus scanners and machine learning and all sorts of, we did a bunch of work in that space with partners, various types of machine learning classifiers to detect malware. And all that stuff is still valuable and it's still useful, but our adversaries learned from that. They learned if they put custom malware onto our systems for any, than the other stuff that was supposed to be there. But now they're often employing living off the land techniques, which means they're simply using commands and services that are in that environment, whether it's Windows or Linux or whatever. And those tools are very powerful. Just look at NetShell, for example, on Windows, common administrator command that's used by administrators all the time, and yet it is extremely powerful and can be used to do bad things. Windows has all sorts of services for transferring files. You can use those to exfil files rather than using your own custom malware. And then all you see is, oh, it's running a transfer service that is part of the local operating system environment. That's a lot harder to see. So we have been sponsoring some analytic activities, looking for living off the land. We have good relationship at NSA with some of the national labs. They have some very smart analysts and computer scientists and mathematicians. And so we partner with them. And that's, I think, very beneficial. But one thing we have found in doing those analytic workshops is that you can't find the sophisticated living off the land behavior if you don't have the right data. And that includes both data about your local environment through how you configured it and how you're monitoring it, and threat data about behaviors that you should be looking for. All right, and that's part of what we're talking about here at this interoperability village, is how to get that stuff moved around in an interoperable way so that multiple tools can use it. And I think that that will be essential to ultimately making the living off the land problem something like, yeah, we can deal with that. It's hard, it's challenging, but we know how to deal with it. From rather than the current state where it's very scary and you have no idea whether you find it or not. Okay. AI is another big area. I'm going to save that for a little bit later, but we generally sort of bin that sort of work into two areas. Using AI to help cybersecurity and using cybersecurity to protect and defend AI. And I'll talk about both of those. Okay. So importance of standards and automation. I'm doing okay in time so far. In fact, I'm
Gobs and gobs
yeah,
of
lots of
time.
time. Okay.
You started early, so you have
Yeah.
a really lot of time.
Okay, well, we're gonna have time for like Q&A and discussion at the end, because I'd really like to get y'all's reactions to some of this stuff. And many of you are in different parts of industry, you see things that I don't, and I would love to hear about that. So defenders, think about somebody working in a SOC or maybe on a hunt team that is going out to a site to hunt for cyber intruders, malicious actors. They have to observe their environment, right? Classic OODA loop. They have to understand and make sense of what they're seeing. And then they have to take some kind of decision about what to do and then do it. There are all sorts of ways that we can improve that workflow for them. Right? We can improve their awareness, which improves their ability to observe and to make sense of what they observe. We can improve analysis, which improves, sort of parts 2 and 3, the sense making and the deciding, right? If you can effectively analyze, then that can support a decision. And then lastly, the response actions, the mitigation, right? There are automation specifications, interoperable ones, many of them being worked on right at this event to support all of those. Okay. Now, one way that you can improve these things is improving the accuracy, right? Can I observe in a more accurate and timely and confident way so that I'm sure I haven't missed any observations or I am monitoring all of the landscape that I need to monitor, right? So it's accuracy, and I'm sort of lumping in completeness there, okay, with accuracy. There's improving the analysis. You can speed up the analysis, right? I was speaking to one of our researchers the other day. There was a certain form of analysis on a graph that they wished to perform, and they managed to cut that down from hours to minutes. Wow, that's great. Because that means you can reach the conclusion of that analysis faster and hopefully take more timely action based on your findings. And that is one thing that I'm proud of our research directorate. We have done a lot of work in sort of algorithms and analytics. That's one of our core research focus areas. Much of that we open source, share with the community. So not to toot our own horn a little bit. But you can speed up the analysis. You can incorporate more information into the analysis. Right? I'm gonna hit that as a key point later, but all of our organizations monitor our environment. But in addition to understanding your own environment, understanding the ecosystem in which you're working and how the kinds of observations that others are seeing is also essential, right? Attackers love it when they get to attack us as individual enterprises or individual networks. Attacking us as a community is harder for them, right? It's lower ROI for them. They're going to get their stuff burned and their techniques analyzed and disseminated faster when we work as a community. And so we can improve that. And lastly, you can reduce cost of analyses. That's important. None of this stuff is free. So if you can utilize data sources more effectively or incorporate capabilities without having to buy new products or new services, well, that's all helpful as well. So we talked about that. And then lastly, improving response or improving mitigation. All right, you've done your observations, you've done your analysis, you know that this thing over here is a problem and you need to fix it. How are you going to do that? Right? Maybe it's an exposure. Block the exposure, or you could maybe reconfigure it, or maybe it needs a patch. Which of those actions should you take first? Which of them is going to have the minimal impact on the rest of your operations or your mission? Those are all important considerations. And doing that effectively requires both an understanding of the action that you wish to take, which is usually not too bad. I'm going to add a rule to my firewall, or I'm going to block a site in my protected DNS. But then understanding the side effects of that are harder. And how will that affect what's going on in my network, in my mission? And all of this is partly about either preventing the malicious actors from accomplishing their objectives, like maybe you catch them early in their life cycle and you say, oh, wow, they're trying to exploit that vulnerability over there. Caught you. That vulnerability is going away. Or maybe it's unfortunate they've gotten in and you wish them to prevent them from achieving their objectives, right? Maybe they've got a foothold on one host, but they're really trying to get to a big server and you prevent them from getting there. The faster you can come up with these actions and execute them with confidence, greater chance that you've stopped the adversary activities before they've reached the point where they're achieving their evil mission, right? Whether it's to exfiltrate stuff or, put something deeply implanted in your network for later access or whatever it might be. Okay. Some specific, let's see. Talked about that. Yeah. We have a brief digression into another area that I've been concerned with lately. We actually managed to publish something about this out of the federal government in early January, and that is software understanding. Right? All of these systems that we're seeking to defend are run in software, whether it's commercial software like the platform or servers or custom software. We have lots of that in the DoD. Some of it is very old. And of course, if you're running any kind of embedded system, right, whether it's a weapons platform or critical infrastructure, right, that's all got software, and some of that might be old. So we took an approach a couple of years ago saying that we need a national initiative in software understanding. And that's not directly applicable to the interoperability goals of this workshop, although it certainly has interoperability goals, right? Yeah. But if we can better understand the software systems we're seeking to protect, then I would assert that we can more effectively protect them. And an initial step in that is just understanding what the heck is in that software. Right? Alan here has worked diligently to advance that cause. Presumably be talking about it later. And that's an important step. It's an essential step, knowing, okay, I've got this piece of software, what are the components that are in it? Or this system and what software components are running on it. But it actually goes beyond that as well. How are the dependencies working? Are there known flaws in some of that software? One of my personal pet peeves is how software systems are composed out of pieces, because sometimes that creates seams where an attacker can come in. I remember seeing one quite some time ago, so a long time ago, where this one software system sent a message to the other about something the user wanted to do. The receiving system assumed that the user had already been authenticated by the sender. The sender assumed the receiver would take care of that. So, all right, we fixed that. But, you gotta make those sorts of dependencies clear. Especially with the huge emphasis on software APIs calling each other furiously between our different systems. So software understanding is a big deal. Like I said, we published a paper, a call for action about that. I think it was like January 17th or 18th, somewhere in there. And you can find that on NSA's website or CISA's website. Yeah, CISA was a co-author, although a lot of it was actually done by experts at Sandia National Labs in concert with government folks. So, and I would assert that if we can improve our understanding of our software systems, that will help make all these other efforts more effective, because we'll be able to do them from a more informed posture. Right? I'm going to take some action on this software system. I understand its dependencies. I understand a little bit more about its operation. Helps me be more confident as I apply those mitigation actions. Sorry for that digression there. Okay, so specific areas about interoperability and sort of cybersecurity automation that I'd like to call out. The first one is STIX. STIX has been around for quite some time. It's gone through a couple of versions. Right, it started out as a great big honking, very complicated XML spec. I believe nowadays it's mostly done with JSON. Probably helped a lot of processing, because I remember seeing it in its XML form back in the day. It's like, whoa, that's complicated XML. But of course, I worked on XCCDF, which was a horrendously complicated XML. So I can't call the kettle black there. So, but STIX is really important. We might say, oh yeah, STIX is old hat. Don't look at it that way. It's still really important to be able to exchange this kind of information. Now, STIX is well along as a standard. It's pretty mature, right? Michael Rosa helped push for some of that. So thank you, Michael. But we still need it. We need to transfer information about actors and about their techniques and about their most recent activities and all that stuff. And STIX is the way to do that. And while it is a mature specification, it still isn't integrated everywhere as much across the community as it needs to be. We are using it at NSA for some of our information dissemination, but we still have other places where we could use it more. And we're working in that direction. And it really helps support a lot of different roles within our sort of cybersecurity defender community, right? From threat analysts to defensive operators, to responders, to hunters, to blue teamers, to system administrators who have to configure stuff and apply patches. It's beneficial to all those folks. But you can't expect all of those folks to read raw JSON either. So you need it integrated into tools so that both for generating it, if there are observations, say, coming out of an analytic, you need to generate STIX, or for consuming it. Maybe you're in some kind of system administration console and you want to consume STIX information so that you can alert, say, a system administrator to configuration errors or exposures. And of course, we can go through tons of other use cases. And then I think an important future area will be utilizing STIX for basically automation workflows between non-person entities, and some of them AI-driven. We certainly have some efforts at NSA and sort of starting to use AI systems and getting them consuming sticks. I'm sure some of you have seen that as well. And that's going to be really important because it's going to enable more sophisticated automated response or SOAR scenarios. Is SOAR still a thing? People still use that acronym?
We argued about it yesterday, whether it was dead or not, so yes.
I mean, people are still doing it, but
Right.
it's so mainstreamed now that people just say, I'm doing security. When that stuff started, it was like a big deal. We talked briefly about understanding our systems, right? Bills of material are still a big deal, right? Certainly SBOMs are like that meeting we were at yesterday, Alan. We talked about other kinds of bills of material, and I presume you may mention those. But my view is that we need means for utilizing that knowledge. It's great that we're collecting it. It's great that people are generating it. We need more people to generate it, and maybe we need some additional rigor in how it's generated. Those are all important things. How do we consume it? How do we take in, for example, an SBOM of a software system and sort of match it up against threat information that we're receiving or blue team findings that they've evaluated in our network or something coming out of a scanner and say, oh yeah, okay, this is important to me. Now, I was reading a little bit about OSIM. I have to admit, I don't understand that particular spec deeply, but it seems like.
Should have heard my talk yesterday.
Oh yeah, I wish I could hear more. Yeah.
It was only 5 minutes.
It seems like it has enormous potential to help us in this regard. So I hope that one is going strong. Another phrase that I've heard a bit, and Michael Rosa told me it might be a concern of this community, is the phrase continuous ATO. That's sort of a government-centric phrase because authority to operate, something that all government agencies use. You can generalize it to basically having continuous up-to-date understanding of the security posture of your systems. And, you know, when I was in our capabilities directorate at NSA some years ago, ATO process was part of what we did. Had to do that. It was periodic. Every few months or years, often it was years, yeah. You would, you know, go to the system, you'd run a bunch of scanning and testing tools. You might do some manual testing or bring in a blue team. And you said, okay, at this point in time, I have a good understanding of the posture of my system. You didn't always have a good understanding, but you know, at that moment in time, it was pretty good.
Well, it uncovered stuff and you fixed them, so
And
you
yeah.
could then say, good.
Yeah, and you'd apply it, you know, so-called POAMs, plan of action or milestones. Because I found 9 things, I got to fix those 9 things. All good. Not so good a few months later. So clearly, we want to be in a position where we understand our posture all the time because that's what attackers do, right? They're not attacking the system as it was when you tested it 3 months ago. They're attacking the system as it is now. And so having information exchange standards and procedures and best practices for doing that, for storing that information and then employing it to do roll-up postures, right? You may run a scanner on an individual system, but that's part of a larger system security plan. You gotta be able to roll that up to give, for example, the CISO, or in government, they call it a designated authorizing official, a picture of how that system is. And of course, they're not going to sit around all day looking at dashboards. They want to be alerted when something falls out of compliance, right? You might have a simple compliance rule that says things will be no more than 3 days behind on their patches. Okay, well, when a system is now 4 days behind, you want to alert somebody. And if it's 2 weeks behind, then you want to send a more forceful alert. So how do you do that? How do you integrate that with the rest of your operational and management processes for your IT enterprise or your cloud workloads? I think is a critical area. And then eventually, sort of pie in the sky vision is that we can extend that understanding of current posture across both on-prem and cloud systems. Today, that's hard because they report a lot of their information differently. You configure them through different tools a lot of the time. But we do need to get there because those systems trust each other all the time, right? Okay, so we talked about that. And I know there's also work here in sort of cloud configuration security in general. I think that's Pascal. And
Yeah, a bunch of them.
yeah, and how that ties into FedRAMP and things like that. Okay, so now I'm going to talk a little bit about AI. Like I said, we sort of divide up our AI work into cybersecurity for AI and AI for cybersecurity. I'll talk about the latter one first. Modern AI systems have tremendous potential to help us with various aspects of cybersecurity, especially scale. Right, all of our systems are big; they're not getting any smaller. We have a lot of monitoring data. It's challenging for security operators, defenders, administrators to know where to look in that sort of giant pile. AI can help us with all of it. It's a little bit tricky because that AI system, if it knows that much about our systems that we're defending, it is also itself a target, right? I remember seeing a demo of a LLM-based tool that would allow you to make natural language queries of all of your monitoring data. It's for a particular cloud service. And it was very nice. You could ask it, how many failed logins did I have between midnight and 6 a.m. in the last 2 weeks? And it would like tell you and show you those log records and all this great stuff, right? But imagine how helpful that is to an attacker. If they could gain the credentials to get to that system, they could say, well, I knew what I did. Am I getting caught? Or show me all the unpatched systems in this environment. That's a great question. So, you know what I mean, right? So AI, super useful, super helpful, but also potentially a target. So we need to be sure and protect it. Another one I think is really important is using AI to help us understand the floods of threat information that are available to us from our partners in the community and commercial threat feeds and other places. In NSA, we also want it to be able to look at sort of the intelligence reporting that we have and maybe mash that up against the commercial data that we purchase. And there's so much of that stuff that AI, we think, can really help there. Okay. And also be able to, I'd say this, sort of help us bridge different concepts, right? So I might have a threat feed that says, this actor is utilizing this attack technique, code number T12345, to attack Linux systems. Then I might have a configuration report out of my cloud service that says, you're running these virtual images, which all happen to be Linux, and you have this software that you're using. How do I link those up? How do I know that attack code corresponds to something that one does against cloud-hosted Linux systems? AI, we believe, can help with that. If you feed it the right kind of training data or the right kinds of vector databases for RAG or techniques like that, you can help folks who are coming at the problem from different angles see that, yes, there's really an issue here. Do that mapping, right? We think that will be important as well. And then finally, we're starting to look into the idea that, well, now I need to take a response action. Can the AI help me plan that? Act as a planning assistant? Not necessarily going to let the AI do it for me yet, but plan out a complex sequence of steps that obey certain constraints. And we're seeing that AIs can do that sort of thing, right? So and eventually, I think we will get to the point where we'll have so-called agentic systems, where the AI will be allowed to do certain things So human on the loop instead of human in the loop. Not sure we're quite there with how much people trust these technologies yet, but I think we'll get there. All right, but now let's flip to the other direction, which is protecting and defending our AI systems. I think there's a lot of issues there. One of them that I particularly care about is as we are deploying AI into our enterprises, into government agencies and big companies and universities, how many tickets are we giving those AIs? Are they allowed to get to all of our enterprise data? Just some of it? I'm actually helping to sponsor a academic summer workshop on this topic, AI risks and mitigations for AI access to enterprise data. Hopefully the students will like that topic and sign up. And because these things are being broadly deployed, I went and did a literature search, like how much academic research is going on this topic. I find almost none. And the ones that were there were very kind of shiny object of the moment, like, oh, yet another type of prompt injection attack. So I think that's an important topic for us because it's like introducing a new kind of agent into your environment. It isn't exactly a person. It isn't exactly a normal web service. It's going to have greater autonomy. It has the potential to hallucinate sometimes. But we are going to give these things power to do stuff on behalf of our employees or even autonomously by themselves. So we have to think about how we credential them, how we monitor them. What does it mean to monitor what an AI agent is doing? It's not exactly the same as monitoring like normal database access because vector databases are not normal databases. And so we think this is very important at our AI Security Center. We're trying to come up with some best practices in this space. I'd say we still have a long way to go, but we're working on it. And many other folks are working on this as well. So that is important too. And lastly, I want to kind of finish up with talking about the importance of the community. I mentioned this at the beginning, right? I've been saying this at public speaking events for years. None of us individually have the visibility that we have as a community, right? Malicious cyber actors want to work in the shadows. They want to conduct their activities without being caught and do their malicious exfiltration or stuff in secret until the moment they present you with a ransom request, for example. All of that stuff requires that they are not successfully observed. And their ROI goes up because they can write a piece of tradecraft or evolve a technique, and then they get to apply it to lots of targets. We want that to be, you evolve a technique, you get to apply it to one target. And as soon as they catch you, everybody else knows about it. And that is now no longer effective against everybody else because we have effectively, and in an interoperable way, disseminated that information so that everybody knows how to defend themselves. And so visibility, I used to always call that shared visibility, right? What one of us knows very quickly, the rest of us know, whether it's through a threat feed or a sticks feed or whatever mechanism. Second is concerted action, right? It's good to share information. We've had initiatives at NSA. I know CISA's had initiatives of disseminating information. Many companies share threat information. That's good. It's boosting visibility. But that's not enough. You also need to take concerted or in some cases even coordinated action, right? And the reasons for that are a bit more complex, but basically if you do things piecemeal, you allow adversaries to sneak away or adapt their tradecraft and maintain their presence in victim networks or maintain their covert infrastructure. We don't want any of that, right? If you're going to try to take down some adversary's covert infrastructure, you don't do it by picking off this one and this one and this one. You do it by going after as many of them as you possibly can all at once. Because that denies them, or at least degrades their ability to reconstitute. How do we do that? We need mechanisms for coordination and collaboration on activities. And some of them are things that maybe only government can do, right? FBI is a close partner of ours. They have certain authorities, right, that NSA does not. We can tip them and say, hey, I think you should go over here. We can't do it, but you can, right? Or a private company might be able to do something on their infrastructure. Hey, you got a malicious actor on your network, probably violating your terms of service. Committing crimes is against terms of service. Go, take them down. But not just at one place, at all the places that they're sitting, right? A big actor isn't going to just sit on one cloud provider. They're going to have stuff on multiple cloud providers, just for an example. So how can we coordinate those actions so that we can be more effective in giving our malicious actors a bad day? I think that is important. So I think I'll finish up with my prepared remarks, and then we can go to some discussion. The work that you're doing and this community and all the people that are out on the Zoom call, it's important. It's something that's going to be foundational it is foundational now and will be even more so in the future in how our community protects ourselves against malicious cyber actors, right? I'm of the opinion that we cannot be successful against the sophisticated actors. Yeah, we might be okay against script kiddies, but against sophisticated actors that we face today without quick interchange of information, interoperable analytics and response activities, and the ability to act as a community when we need to, is all enabled by the technologies you guys work on here. All right, so time for Q&A.
Yep.
Do we have time? I think
Yep,
so.
we have 10 minutes.
All right, I think your hand is up
Yeah.
first.
Everything you talked about hit home with me. Comes from the beginning of data being inoperable, data being sharing, starting with a format. Who's that going to feed? What job functions? And then you start talking about AI, and you're saying, well, data is, but all the data out there on a major thing is sometimes illegal. But if you look at data that's contained within your organization, like a rag, then you've got a legal boundary over the data.
Yes.
A lot of companies today, I think Nivea, have individual rags per job function within the company.
Often they do, yeah.
Each job function says, this is the work that I do. Here's the input data I need. Here's what I'll do with that data. And then here's what happens with the data afterwards. So there's a function string going down the line from beginning to end. You look at the sticks. People have to fill out the sticks because I'm reporting a cybercrime, some tort, some type. Just like they have to fill out a problem report. So I have a problem sometime. Problem report goes to national and NIMS management, it's a system. So the same thing with sticks, it's going to have to go someplace else. So if part of the RAG functions say, here are the security people, then the one thing I never heard you saying when you talked about analyzing these security threats is who are the people involved? Because I did security too, and I found there's always somebody in the organization beating it. So I wanted to get those people to feed in as well as all the analytics that I'm gathering. So the people function is an important aspect. So you can gather information from the people within their job function. That information has to be taken out and formatted via sticks to be able to be useful. So you're saying that as every job function within this bound of data has the ability to generate formatted information that I can use to feed multiple systems.
Okay, yeah.
And then from those systems, I can then feed out.
Yes.
Because you got data coming in that has to be interpreted and sent to job functions. The other has to come out too. You have to take job functions, find out when they discover information and bring it back.
Okay.
So by doing that, you've got the many doing what you want rather than the one.
Yeah, I think that is all true, but there are challenges to that vision. People in particular, right, have certain privacy rights and government, right, PII is protected and so forth. So you might have a job function that is looking, for example, at insider threat, which, you know, often can also find things like people whose credentials have been stolen, somebody's masquerading as them.
Right.
But that information
But
might
they
be
could also
controlled.
uncover something you just, because you're talking about the known unknowns,
Mhm.
right? So now you've got internal people that you hadn't put into your sequence of gathering data. But now all of a sudden this known unknown turns around and said to you, hey, I just figured a way of beating your system. So you've got something that's helpful inside. It's not always a negative. Could
Yeah,
be a
no,
positive.
I agree, it's positive. It's just how do we integrate it and how do we protect it? Same as any other enterprise data. All right, let me go to Tom, your hand is up next.
So, you talked about AI for cyber, you talked about cyber of AI. You didn't talk so much about the adversary's use of AI. And where I'm specifically going with this is, and I've asked some of your colleagues,
Mhm.
have we seen the adversary kind of really going to autonomous agentic use of AI against us? And I realized in asking that question, I don't know that we know what that looks like. So have we done any work on simulating that, or so run with that?
I'll try.
Yeah.
We've certainly seen adversaries using AI in simple ways, like to generate phishing emails and personas, right? That's well known. I have not yet heard about them using it in what we might call sophisticated agentic ways, to take advantage of, say, AI-driven automation to actually do an entire task. I've read academic papers along those lines, to the point where some academics are able to go to an AI and say, there's a system over there, it's running this software, you know, attack it. And the system was able to do so. Good academic research. Haven't observed that yet, but as you point out, how would we know? I'll be right with you.
I can have the next one, Neal.
Okay, sorry. And I think that's a challenge. We actually had it on a list of challenges for internally while I was in the cybersecurity directorate of what instrumentation, what analytics, what data would we need in order to make that call? This is a human adversary doing that versus they have, like, you know, a lang chain based workflow doing it for them. And I don't think we know yet. I think that's still open research. We're next.
Yeah, so from the web.
Yeah.
So you're now the, I'll reword it, my words. You're now the chief techie of research at the NSA. What do you see as, I won't call it the next big thing, or the next big thing we already know the buzzwords of. What do you see a little bit further down the road? Because you probably have a little bit further look than most of us have.
It's a really good question. I think something we definitely are seeing coming down the pike is more sophisticated agentic type interactions, right? Things tend to be very, very coarse grained today. And we see that becoming more, I think, more fine grained, AI more tightly integrated into sort of human activity loops, helping the humans make sense of things, being an integrated team member. The strength of current LLMs is probably already sufficient to do that. It's more a matter of how do you actually implement it. And then as the AI systems get more sophisticated, we're advancing towards what people might call weak artificial general intelligence. I saw an article just this morning about somebody claiming GPT-5 has actually reached that. A little skeptical, but we're getting there. And what do you do once you have that? I think is a serious question that we need to think about. Both how do we leverage it, right, for our missions and for cybersecurity, and then what do we do as adversaries start to leverage it, like Tom was saying. And then beyond that, we're seeing a bunch of other stuff in terms of, say, very, very dynamic systems. All of our IT systems are continuing to get more dynamic. And how do you monitor that? How do you protect it? How do you know what's in it? Right? It won't be, I get an SBOM from the system when I buy it. I've got to have continuous SBOM or something. And as part of continuous understanding, and that's going to be tricky. So, all right, back
So time
there.
for two more questions,
Okay.
one there and then one off the web.
Okay.
No, thank you for your comments this morning. Want to just follow up on your AI for cybersecurity. You talked about using AI to do planning for response, and that would be with planning humans to do a response.
Yeah.
But in the national security world, you have no-fail missions that have to recover, not just respond, but recover and operate at all times. So how would we be using AI to support those no-fail missions when you don't really have time to have a human interact with an AI and take a recommendation from an AI, but have the AI actually do the response, do the recovery of the
I think
system?
there's two angles to that. One is for those no-fail missions, at least the ones I'm familiar with, they plan out things in advance, like all the time.
Yeah.
Right, so they try to envision the different forms of failure or compromise, and then they already have a plan on the shelf. If this happens, then my response plan is this. And so AI can help us to build those, make sure they don't have gaps, make sure we have a complete set of them, pick the right one, help us pick the right one quickly, all that's valid. Next thing is back to what I said earlier about tighter integration, that if you're really up against really unknown circumstances and you have to plan on the fly, there may be information overload to the human who's trying to say, oh, it's the middle of the night, I've had this incident, this is a no-fail mission, it has to be back online in 5 minutes. What am I going to do? That is something where I think AI can help deal with the information overload, get the human down to the most critical, most high priority items. Some of these no-fail systems have incredibly complex rules and procedures that are that govern them. And AI can help the operator find the ones that need to be employed or need to be satisfied. So I think there's potential in all of that.
Thank you.
So one final question,
Okay.
again, I'm gonna reword from the web. So when I first started working with the NSA, it stood for never say anything, and you guys were extremely private. You now have more open work. You mentioned Mike Rosa earlier. The standards effort of the NSA is now a much more open and collaborative effort. The question from the web was basically, how do we follow along the work that you're doing in NSA research, and how do people get involved or know what's there?
That's a fair question. So there's a couple of ways, and it may depend at least partly on the research area. And some of our research, of course, still squirrely and kept secret. Right? But for the cybersecurity research, for example, which is generally quite open, we will post documents on our own website. We'll post things in concert with other government agencies, CISA, somebody whom we frequently publish stuff with. We'll publish academic articles. We'll open source software. Right? We have a GitHub with dozens and dozens of things on it. We publish things with national labs partners where they speak at conferences about the research they did in mathematics or analytics or various cyber topics. And then lastly, we try to contribute, as Duncan said, to standards, right? We're active at the IETF. We're openly on the mailing lists. A big focus, for example, for us right now is making sure that post-quantum crypto is effectively integrated into various protocol standards so that we can use them and have confidence in them. And we're out there, right? My friend Mike is very active in IETF, and he is on those mailing lists, and you can follow what he's saying. So it's sort of domain dependent, right? IETF works differently than ITU, which works differently than OASIS. But we try to be very open about our activities in all of those.